Alrighty, here's the second group of problems, and because of the way the system is set up, I have to start at the beginning every time and then go to the problem. So be patient, please. Our first problem, problem number 6, will be problems 6 through 10. The perimeter of a pentagon, a 5-sided polygon, is 50 inches. The 5 sides are represented by consecutive integers. That means one number right after the other. Find the lengths of the sides. So first of all, we have x, then we have x plus 1, we have x plus 2, then we have x plus 3, and finally x plus 4. Our perimeter is 50, so we will set our equation up where it is equal to 50, and we have x plus 1 plus x plus 2 plus x plus 3, and finally plus x plus 4. The pad where I'm writing on started moving and it's like, uh-oh. So we have 50 is equal to, we have 1, 2, 3, 4, 5 x's. So that's going to be 5x plus 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. This is a little easier to solve now. If we subtract 10 from both sides, that's going to leave us with 40 is equal to 5x. We can complete this over here. We have 40 is equal to 5x. Next, we divide both sides by 5 because we want to isolate the variable. So we know that x equals 8. So now we can put x equals 8. 8 plus 1, sorry, the screen, equals 9. 8 plus 2 equals 10. 8 plus 3 equals 11. And 8 plus 4 equals 12. And those are our results. Now, what I need to do is move the screen up so that I can put the answers in there. Let me see. Let me pause for a moment so you have time to write everything down, and I'll put everything back to where it was. Okay, I hope you got everything written down because I need to erase so that I can write the answers in here. So we had 8, 9, 10, 11, and 12. Problem number 7 is another consecutive numbers problem. The sum of the page numbers on two facing pages in a book is 797. What are the page numbers? So we would set this up as x plus x plus 1 equals 797. Frustrating sometimes. So 2x plus 1 equals 797. And some of you are going, well, why can't I just divide it by 2 and then subtract 1? There's more than one way of solving a problem. If that works for you, then fine. Try that. So now we're going to subtract 1 from both sides, which leaves us with 2x equals 796. We divide both sides by 2, and that little bar down at the bottom with all my trusty tools, so that x equals 398, and then x plus 1. Can I move this? Yay, okay. X plus 1 equals 399. So when we add these together, this is 7 plus 1 would be a 9, and then a 7. So I'm sorry, this little toolbar at the bottom blocks me from writing below a certain point. So we have 398 and 399. And let's check. Great. And let's move on. Oh, let's erase first, and then we'll continue. Now we're getting into set builder notation and interval notation. Graph the set and write the set in set builder notation in terms of x. That means that's the variable we're going to use. Notice we have parentheses. So that means that we are not going to have an equal bar under our inequality sign. The graph of this set, first of all, let's look at what 3/2 would be. We know that 1 would be 2 over 2, right? So we would have 1 left over. Let's look at how they're counting on the number line. And this is positive, okay. So we have 0, half, 1/4, 1/2, 3/4, 1. So here's 1, which means this would be 1 1/2. So we're going to start and put this right here. Okay. Next, we'll get the interval bar or line segment, and this is going toward negative infinity. So that's how we would do that. Let's check it and see. Oh, sorry, I have to do everything at one time. Okay, so we have x such that x is less than 3/2. So let's go here. We're looking at set builder. We're going to put our x such that x is less than, and here's our fraction, 3 over 2. Now let's check. Okay, that's encouraging. Now another way you could write this would be, you could say x such that 3/2 is greater than x. Both of them are correct. They're just written differently. And notice the inequality sign. That's what makes the difference. Let's continue or move on to the next problem I was trying to say. So for this one, we've got three parts. Solve the inequality and graph the solution set. Write the solution set in A, set builder notation, B, interval notation. So there are three things we're doing, and express the numbers in simplest form. The first thing we have to do is solve this. So we have 16 is less than 8x minus 8. Okay, we want to get all of our constants on one side. So let's add 8 to both sides. That gives us 24 is less than 8x. I'm going to finish over here. If we divide both sides by 8, then we find that, and notice we did not use any negative numbers, so we don't have to change the direction of our inequality. So we have 3 is less than x. This time, we're checking as we go along. So the solution set is written in set builder notation as x such that x is greater than 3. Let's see what happens if I change this around. Because the way we have it written up here, what if I put such that 3 is less than x? Okay? So you could write it either way, but it is preferred that you write the variable first. So that's our first part. The second part, written in interval notation, x is greater than 3. So we don't have the equal bar, so we know that's going to be two parentheses. And we're starting at 3 because x is greater than 3. So we'll have the 3 first, and that means this is going to infinity. Let's check and see if that's right. Yay. So now to graph it, I need to erase what I have on the screen. Okay, so we know that we're working with parentheses, and I'm going to start with the left parentheses because we're going toward infinity. We're going to put that right here on the 3, and then we'll get our interval and take it toward infinity, and then check. Okay, so those are those 3 steps, and this is what I wanted to point out. When you go back up here and they have the 3 little dots, it says your answer is correct. However, by convention, the variable you solved for is written at the left-hand side of the inequality. So what that means is that the first way I entered it, where I had x is greater than 3, is what is most accepted. So just keep that in mind. The last problem for this set, determine if the given ordered pair is a solution to the equation. So this is our y variable. I can only write it right. So that this is our y variable and this is our x variable. So we're going to say that -2, and we want a question, so we're going to put a question mark there. Does that equal -2 times -3 minus 8? So we'll have -2, and we don't know yet if it's equal to -2 times -3 would be 6 minus 8. That's going to give us -2. So this is indeed, sorry, that's a z. It's supposed to be an equal sign. -2 is equal to -2. So our ordered pair is a solution. And that concludes our second group of problems 6 through 10.